Hi, today we are going to discuss about the binary search applying divide and conquer principle, how we will search a particular element in an array. Suppose there are 14 elements in an array. Suppose these are the elements. So whenever we are going to search a particular element in an array, so in case of binary search, what happens? We should have to take an index value that is called as the low value, and we should have to consider the end index that is called as the high value, that is h. So in case of binary search, what we should have to do, each time we should have to find out the mid of the elements. Actually binary search in case of divide and conquer, it can be solved in two ways. That is, one is your iterative way, another second one is your recursive way. So here we are going to solve it the iterative binary search. So in this case what will be happen, we should have to check first the lower index and the higher index. Suppose there are 15 elements are there, our n is equal to 15. We need to solve to find out a particular key element. Suppose this is 42. In case of sequential search, what happens? We need to search each and every element starting from the array first index to the end index. So at least we have to read n number of elements. That is why its time complexity is order of n in case of worst case and average case. But in case of binary search, how divide and conquer principle is applied and reduce the time complexity, that we will analyze it. Suppose I have taken my low value first 0 and high value is 14. So what I have to do, I have to calculate the mid value. So here my mid value is 7, that is 14 plus 0 by 2, that is equal to 7. So now we will check each time whether my key value is equal to my mid value or not. So here this is the mid means, so array of mid means array of 7 is 29, whether my key value is greater than this or less than this. So in this case my key value is greater than the a of mid value. So what we have to do, we have to search the second half, not we are considering this, because binary search principle is the array should be in sorted order. So what we have to do, now we have to consider our low is equal to mid plus 1. That means our low we will calculate, that mid value is 7, we will take low value as 8 and high will be same. Now again we will calculate the mid value. What will be our mid value? Mid value is 14 plus 8 divided by 2, that is 11. Now we will check whether our mid value is array of mid, whether our key is array of mid, a of 11. Now a of 11 is 47. Our key is 42. So we should not have to go further, because binary search principle is array should be in sorted order, age it is less than, so our key is behind this, means it be in between this. So what we need to do, we will reduce our high to mid minus 1. So low will be same and high will be mid minus 1, that is high will be 10. Now we will again calculate the mid value, that is 10 plus 8 divided by 2, that is equal to 9. So now a of mid is 9, a of 9 is 36, whether our key is greater than 36 or not. Yeah, our key is greater than 36, so our key is in the right side. So what we have to do, we have to increase our low value, means low value will be mid plus 1. So low value will be mid plus 1 means mid is 9, low value will be 10 and high value is already 10. So mid will be 10 plus 10 divided by 2, that is equal to 10. Now we will check a of a mid, a of 10, that is 42. Whether it is our key? Yes, it is our key. We have to return that index, means the mid index we have to return here. We have to return. Now this is the procedure for iterative search. Now consider this, how many comparisons we have done this. In case of sequential search, what we need to do, now we are searching from here at least 10 elements are there, or 14 15 elements are there, we are reading at least 15 elements. But in this case what happens, we are reading only within 4 comparisons we are getting our value. Now if you will write the algorithm for iterative binary search, then what we need to do, we have to write that binary search, and what we need actually 3 things. One is our array, another one is our number of elements n, and another one is your key value, what you need to search. In between this, here I am writing the function instead of algorithm, I am writing the functions. So what we have to do, now we have to initialize our low is equal to high, low is equal to, we have to initialize it as 0, and high we have to initialize it n minus 1. N is the size of the array. Now what we need to do, we have to divide the mid equal to low plus high divided by 2. Now we will check if our mid value is equal to key, then we will return. Simple thing. So we will check if our key is equal to array of mid, then we have to return that index. Where is that index? Mid. So you have to return mid. We got it. Else what will be happened? Else if the key is greater than a of mid, then what we have to do? If our key is greater than the mid, that means in the right side the element is available. So we have to increase our low. So low is equal to mid plus 1. Else high is equal to mid minus 1. Otherwise it will be in the less side. If it is not greater than, not equal to, so definitely it is less than. So if it is less than, then we have to reduce our high to mid minus 1. These things we will continue till we are searching, suppose low here, high here. So now our element is there, so we are increasing low. If our element is right side, again increasing the low. When the low is greater than equal to high, up to that we have to continue in a for loop. So we have to take a while loop here. Low less than equal to high, we have to check. This is our condition. And after this condition, if you will not get the value, then what we will do? Now we will return 0. That's all about iterative binary search. This is our binary search. So now I will draw the tree in front of you. I will take you what is the time complexity for iterative binary search. So what we did here, we have divided, suppose we have 15 elements are there, so 0 to 14. So we have calculated the mid. What is the mid value? Mid value is 7. First we have calculated. Then what we did, now we have taken 0 to 8 to 14 another side, and here in this side also we can say that 0 to 7 elements are here. Again we have divided into 0 to suppose 3 and 4 to 7. Here suppose 8 to 11 and 12 to 14. Likewise we have divided. Again we have divided this, again we have divided this, and like this we will divide it. So here I already told you that in this algorithm after 4th pass we got, after 4 comparison we got it. So that means in our array is in the index 10. So here where we will get the 10th index, you check. First it is not available, second it is not available, third it is not available. Now it will be 8, 9, 10, 11. So here we will get it. So that means this is first, second, third, fourth. First comparison, second comparison, third comparison, fourth comparison. The height of the tree is here 4. So according to the tree comparison, the height of the tree is always log n for a binary tree, right? If the height of the tree is a log n, the iterative binary search, worst case and average case time complexity is equal to order of log n. So this is all about iterative binary search, and after this my next video I will explain about the recursive binary search algorithm and its time complexity. Thank you.